This is the ALEKS help video for 8.2, area of regular shapes. It says find the area of the triangle below. Be sure to include correct units. Area of a triangle, base times height over 2. Base and height always makes a right angle, so that would mean 4 is our height, which implies 16 is our base over 2. You could take the 2 into the 16 or the 4, it doesn't matter. And our area here is going to be 32, check for units, feet squared. A regular heptagon has a side length of 5 feet and an apothem of 5.2 feet. Find the area of the heptagon. Any area of a regular polygon, and you have to see that word regular in order to use this equation. Regular means all the sides are equal, as well as all the angles by implication. An area of a regular polygon is perimeter times apothem over 2. Perimeter, always, always, always physically trace the perimeter. 1, 2, 3, 4, 5, 6, 7. So my perimeter is 7 sides times 5. That's my perimeter. Times my apothem, which is 5.2 over 2. This is 35 times 5.2 over 2. 35 times 5.2 divided by 2. We get 91, check for units, feet squared. Number 3, a regular polygon, pentagon specifically, area equals perimeter times apothem over 2. Has a side length of 11.6 and an apothem of approximately 8 centimeters. Find the area. Let's trace our perimeter. Perimeter, we walk it around, 1, 2, 3, 4, 5. So our perimeter is 5 times 11.6 times our apothem, which is 8, divided by 2. So 5 times 11.6, that's my perimeter, times 8, divided by 2. We get 232 cm squared. That's our area. A regular octagon, again, see that word regular. That means we can use this equation. Perimeter times apothem over 2. Has an apothem of 3 centimeters and a perimeter of 20. Find the area. Notice it doesn't give you the side length, but it does give you the perimeter. So that P we already have. That P goes right there. The apothem goes there. So our area equals perimeter, which is 20, times apothem, which is 3, over 2. Our area is going to equal 30 centimeters squared. Says find the area of a regular hexagon with an apothem of 6 centimeters. Write your answer in simplified radical form. Remember, area equals perimeter times apothem over 2. So we have a glaring omission here. We have no side length. So that's obviously something we're going to have to find in order to solve this problem. So let's come in close. There's a trick here. Step 1 is I'd like you to draw in all the radii. 1, 2, 3, 4, 5, 6. Now, look just at these central angles. 1, 2, 3, 4, 5, 6. You see, to find that central angle, it's basically 360 divided by 6, of course, which is 60. That gives us, this is 60, which forces this angle right here to be 30. Let me pull this triangle out because what we have here is a 3069D. Short leg root 3, short leg times 2. We're ultimately looking for the squiggle here. The squiggle's the short leg. Short leg to long leg, root 3. Short leg to hypo times by 2. It reads like this. Something times root 3 gives us 6. Something times root 3 gives us 6. We're going to backtrack here. And I know a root 3 has to go in here at least to get rid of that. That gives us 3. And what times 3 is 6? The answer is 2. So this short leg is 2 root 3, which means our entire side length is 4 root 3. So now we come up here and our perimeter, our P, is going to be 4 root 3, that's one side, times a total of 6. 4 root 3 times 6. All of that is our perimeter, times our apothem, which is 6, over 2. Outies talk to outies. It doesn't matter which one you take that 2 into. I'm just going to bring it here. So 2 times 6 is 12. Times 6 again is 72. Our area is going to be 72 root 3 meters squared. That's exact simplified form. Said, find the area of the equilateral triangle with a radius length of 6. Okay, radius. Wow. Now, there's 2 ways you could look at this. You could look at it as a triangle, and in that case, it's base times height over 2. Problem is you have neither the base nor the height. But because it's equilateral, it also qualifies as a regular polygon, which would be perimeter times apothem over 2. In this case, our perimeter, of course, I would have to find a piece of a side length. Our apothem centered down. That's our apothem. So let's look at this triangle very, very carefully. If it's equilateral, we know instinctively that all 3 angles are 60 degrees, which makes this particular triangle, we're going to pull it out here so it's easy to work with. This triangle right here is a 30, 60, 90 triangle. We don't know the apothem, we need it. Our hypotenuse is 6 meters. This black piece, which is half of a side length, we're going to call y. This is 30. This is 60. 30, 60, 90. Short leg root 3, short leg times 2. So to solve here, we ask ourselves this. What times 2 is 6? And the answer there, of course, is 3. So we just found our apothem. Our apothem is 3. Times root 3, that would make this 3 root 3. Which means our side length here is double of 3 root 3. That would make it 6 root 3. So our perimeter is going to be 3 sides times 6 root 3 times our apothem, which we found is 3, over 2. Again, the 2 can go in anything, but obviously I'm going to put it into the 6. That's the easiest. So we ask ourselves, what's 3 times 3 times 3? 27 root 3 meters squared.